Mark your own. Here we go. Oh, my favorite student, good old Anne. So each of these graphs is worth 1 mark, so number 1 will be worth 2 marks in total. I'll show you the shape, and then I'll tell you what I'm fussy on and what I don't care about. So it wants us to sketch, so I'm not going to worry about labeling my axes and title and all that. I'm just sketching the following. Okay, a fast buggy starts ahead of the origin. How would I show ahead of the origin? How will I show that? Okay, so I'm going to be fussy. You have to have started above 0. If you started at 0, you lose a half mark on your first graph. And then going forward at a constant speed, I'm looking for a positive slope straight line. That looks curvy. Sorry, I can do better than that. Positive slope straight line for 1 mark. Probably because it says a fast buggy, I might even go steeper. I didn't because if I went steeper, I run into the writing, and that's just yucky. But if you wanted to, I'm fine. I don't care how steep you are, Sally, but for the full mark, it has to start above 0, and it has to be a positive uphill slope. What would the velocity time graph look like? Forward at a constant speed? I'm looking for a horizontal line above the x-axis. I don't care how high. 1 mark. Number 2. A buggy is located ahead of the origin and is at rest. Located ahead of the origin, I'm looking for you to start above the x-axis here. At rest, on a position time graph, that's a horizontal line. At rest, on a velocity time graph, is also a horizontal line, but it has to be 0 high. It has to be on the x-axis. 1 mark, 1 mark. A buggy starts far ahead of the origin, moves backward for 3 seconds, then stops for 2 seconds. Moving backwards for 3 seconds would go like that. I'm going to put a 3 right there. You don't have to. I'm just doing that so you can see my thinking. If you didn't put numbers on your x-axis, I'm not too fussy on that. Then stops for 2 seconds, which would make that 5 seconds in grand total. That's supposed to be a horizontal line. You know what? It's a hockey stick. It's a hockey stick. Okay. Half mark for going downhill, slanty, starting up high, and then a half mark for the horizontal chunk. What would the velocity time graph look like? Moving backwards, below the x-axis for 3 seconds, and then stops for 2 seconds, which would be 5 seconds in total. Again, Sally, if you didn't put the numbers on there, I'm not going to be fussy. I'd look for a horizontal line below the x-axis and a horizontal line on the x-axis, and technically that second line should be shorter than the first line because less time. A fast-moving buggy starts ahead of the origin. Oh, it's going to move forward. I'm going to have to give myself some room. Starts ahead of the origin, moves forward for 2 seconds. Yeah. Stops for 1 second. Yoink. Moves backward for 2 seconds. Something like that. Like that. The velocity time graph would look like this. Moves forward for 2 seconds. Stops for 1 second. Moves backwards for 2 seconds. Again, I'm not fussy if you didn't put numbers, but I'd look for a line above the x-axis, a shorter line on the x-axis, and then a line below the x-axis. So that page is out of, if you want to, 8. Back page, I'm going to be fussier because they gave us numbers. For each position time graph, draw the corresponding velocity time graph. Well, velocity shows up as the slope. So the slope of this graph is 1 over 1, because 1 divided by 1 is 1. Just saying. So I'd be looking for a line like that, exactly 1 high. Okay. The slope for this section, well, the rise is 2 and the run is 2. So for the first 2 seconds, we're 1 high. And then it looks like I have a negative slope, so I'm going to be down here. And the rise is 4, and the run is 2. 4 divided by 2 is, but negative. I would look for negative 2 high down there. Half mark for the first line, half mark for the second line. This first chunk, up 2 over 1. So for the first chunk, we have a velocity of 2. That's for 1 second. And then it's up 2 over 4. 2 divided by 4 is 0.5. I guess for the remaining time, we're halfway. We're 0.5. Half mark for that, half mark for that. Then the last 3 questions, these are thinking questions. So first of all, it says rank them from smallest distance traveled to largest distance traveled. I wrote the distance next to each one of these really quickly. I said, okay, here I went 4 meters because I started at 0, ended at 4. Here I went 2 meters forwards, 4 meters backwards. Here I went 6 meters. Here I went 2 meters forwards and then 2 more meters forwards. Here I went 4 meters. So I guess if they want me to go from from smallest to biggest, you could either go 5, 7, 6 or 7, 5, 6, because 7 and 5 is the same. You know what? 6 has to be the last one. It's definitely the largest distance traveled. So that's what I'd be looking for in number 8. Make sure that 6 showed up last. Let's repeat the same thing, but for displacement. Okay, displacement. Displacement is a vector. Displacement is your change in position. I started at 0, I ended at positive 4. My displacement is positive 4. I'll put the plus signs in because I noticed both those questions are talking about positives and negatives, so why don't I put them in just so I don't have to think so hard. The displacement here, I started at 2, I ended at 0. I guess I went 2 meters backwards, or I have a displacement of negative 2. Here, I started at 0, I ended at 4, my displacement is positive 4 meters. So if they want me to go from most negative to most positive, the only key is 6 has to be first, and then you can have 5 or 7. Am I wrong?
The graph goes to 5 now?
The time goes to 5, but not the position. Right? Right? Yeah. So 6 has to be first, and then you can have 5, 7, or 6 has to be first, and you can have 7, 5. Now that is going to make a difference, by the way, for number 10. Oh, yes. Because now they want me to find average velocity. Well, velocity is the displacement over the time, and I just wrote all the displacements next to each graph. All I got to do is use the time and divide. Okay, so the first graph, the displacement was positive 4. The time is 4. Bryce, in your head, 4 divided by 4 is? 1. I knew you could. And I'll even put positive 1 meter per second just to remind myself, because it's asking about from negative to positive, so I'll do that. The second graph, the displacement is negative 2. The time is still 4 seconds. Bryce, you'll agree with me, negative 0.5 meters per second. The third graph, the displacement is positive 4. But Paige, what's the time of this graph here? So I think I get positive 0.8 meters per second. So here, if I go from most negative, it's going to be 6 is first, then 7, then 5. Yes? Yeah? Can you give yourself a lovely score out of 14, please? If you need to lawyer with me, now is the time. Otherwise, once you put your score on it, make sure your name is on it, you can pass it inwards, and the person in the middle can put it in a nice, neat pile, and I'll come collect them. So last day, we started looking at relative velocity and relative speed. Just to jog your memory, you use this, your trigger for this, Sally, and there's going to be questions like this on your test. You'll know we're in relative speed or relative velocity land when there's 2 objects moving with different speeds. Because we're not going to treat both objects moving at different speeds. We're just going to use their relative speed. In fact, I hardly ever use relative velocity. I don't really care about forwards and backwards. I'm just going to use relative speed. And we said, basically, if they're heading towards each other, add the speeds together. That's why head-on collisions are so bad. If they're in the same direction and you want to find their relative speed, just go bigger minus smaller. And then the nice thing is, we can use distance equals speed times time, except we can use the relative speed. And we can solve for time, or solve for distance. Okay? Thank you. I showed you a video of an airplane that had a relative speed to the ground of 0, but a relative speed to the air of taken off. We did a lovely train question. I think I said I like this question, and we paused here. A great example of relative speed are airport moving walkways. So, as you hurry to catch your flight at the local airport, you encounter a moving walkway that's 85 meters long and has a speed of 2.2 meters per second relative to the ground. Suppose it takes you 68 seconds to cover the 85 meters. Got where we are, Raven? Good. Suppose it takes you 68 seconds to cover 85 meters when you're walking on the ground. How long will it take you to cover that same distance on the walkway? All right. Let's use our DFIC approach. Let's list things. What's this question asking us to find when it says how long? Let's write down T equals question mark. I guess the distance we're going to cover is 85 meters. Is there more than one speed, more than one thing moving in this question? I think so. There's the walkway and the walker, U. So we are going to use relative speed. Got a bit of a problem here. I don't know the relative speed. How fast is the walkway moving, Jaden? How fast are you moving? Does it tell us? Draw the line like that. And let's label this over here walking. Maybe they gave us enough information that we can calculate our walking speed. So I'm going to call our speed v for speed. V vector is velocity, v no vector is speed. And how about v walking is, I don't know. What haven't we used yet that this question gave us? I don't see meters per second. Oh, the 2.2? I think we're going to use that, but I think we're going to use that later on. In fact, I think over here, this is going to be, you know what? I'm going to do this. I know you guys can't, but just to be organized, I'm going to go like this. Don't you wish you could do that? This is going to be on the walkway. This is going to be on the ground or while walking. So I think I'm going to use that 2.2 over on the left in the walkway section. What else have they given me that I haven't used yet? What is that 68 seconds? What is that 68 seconds? Not how far. It's not how. Can you give me a word that begins with the letter T? It's time. And apparently that's the time to walk 85 meters. Is that enough for me to figure out my walking speed? Yeah. I do have an equation that has distance and time in it. I think this one is on your formula sheet as well. Can you read that okay, Raven? Yes? Okay. It's as big as I can make this on this screen, sorry. It looks like when I walk on the ground, I can cover 85 meters in 68 seconds. My walking speed is whatever 85 divided by 68 is, which is what? Using your phone for a calculator? Really? Oh. Won't let you do that on the test. 1.25, is that what you said? Okay. 1.25 meters per second. So you ready, Zach? Here's our thought. This is how fast I walk. This is how fast the walkway moves. What's the relative velocity when I'm on the walkway relative to the ground? How would I calculate that? Would I add them together, or would I go bigger minus smaller? Someone said bigger minus smaller. Someone said add them. Which one? Why add them? First of all, have you been on the walkways? Do they make you go faster or slower? Add them. Unless you decide to be one of those people who likes to go in the opposite direction. And I see those people once in a while. They must be really tired coming off their flight because they are walking kind of oblivious against the walkway and wondering why it's taking them so long to get anywhere. And okay. So I think the relative velocity or relative speed is going to be 1.25 plus 2.2. The relative speed is going to be 3.45 meters per second. So I just took it one step further here. McKenna, I said, okay, I know it's going to be a relative speed thing because there's two things moving. But this time they didn't tell me how fast one of the things was moving, but I could calculate it. Now, I know I have this equation here. I want to get the t by itself. What's the v doing to the t mathematically? Adding, subtracting, multiplying, or dividing? So how will I move the v over? So you're telling me I can go divide by v, and t equals d over v? Ooh, I like that. A new equation. T equals d over v. 85 divided by 3.45. 24.6. Anybody else? How much time did we save? Well, normally it takes 68 seconds. I just did it in 24.6 seconds. I saved 43.4 seconds. Now you may look at that, Jordan, and say, well, big deal. Actually, for airports, that's a huge deal because the faster they can get you to your plane, the more planes they can cycle through. Each one of those walkways costs a lot of money to build, but they're investments. They make their money back. The more people we can push through an airport, the more planes we can push through an airport, the more money the airport's going to make. So it is an investment. Those add up. Is that okay? And I like to put a box around my final answer because, yay, I'm proud. All right. B, you may have done this at an airport. What if you do decide to walk against the walkway? So how long would it take you to cover that 85 meters if once you get on the walkway, you immediately turn around and start walking in the opposite direction with a speed of 3.1 meters per second? Yours says 1.3. Can you cross out the 1.3 and make it 3.1? It was a typo. Because if the walkway is going 2.2 forward and you're walking 1.3 against it, you're still going to end up going backwards and you're not going to get anywhere because the walkway is going faster than you. Okay. What's this question want me to find? Hey, let's do our... Yeah? Hey, did they give me a distance? How far? Oh, 85? Is there more than one thing moving? I'm going to use relative speed. Now, this time, I'm going to draw a little picture. I'm going to doll. Here's what we have this time. I'm walking this way at 3.1 meters per second. The walkway is going that way. How fast? Right? What's my relative speed? Now, if it was cars moving towards each other, we just added them. I don't think we're going to add them here, even though the arrows are pointing towards each other, because I don't think I speed up by going against the grain in a walkway. What's my relative speed? What am I going to do with those two numbers? Bigger minus smaller. So I can do that in my head. Is it 0.9? Okay. .9? And they want me to find time? I guess if I wanted to, McKenna, I could go d equals vt, and then how would I get the the t by itself? Time, but you know what? I've got the equation sitting right there, don't I? So t equals d over v. It's going to be 85 divided by 0.9. 85 divided by 0.9. It's going to take a while. 94.4 seconds. Last one, example 4. I like example 4, I like example 4, I like example 4. Example 4 is a nice question. The police are in hot pursuit of a car which is 320 meters ahead and going 150 kilometers per hour. If the police are going to ram the car in 20 seconds, what must their velocity be in kilometers per hour? All right. This looks like a really tough question. It's not too bad if we don't panic. First thing I want you to notice, Mackenzie, is there more than one object in this question moving at different speeds? This is a job for relative speed. Okay? What's this question ask me to find? What's this question asking me to find? Velocity. I'm going to be fussy. Going to come back to Mackenzie again. Is there more than one object moving at different speeds? I'm going to end up finding the relative velocity. Okay? In fact, I'm going to give you a little hint. Over here, just draw a little line about 2/3 of the way over. We're going to find the relative speed. The relative speed. We're going to pretend, mathematically, we're going to pretend that the bad guys are standing still. I don't care about that 150 yet. If the bad guys were standing still, how far does the police car have to travel? How much time does the police car have to do that in? Is that okay so far? Yeah. Is there an equation that has a v, a d, and a t in it? There is. In fact, I think there's even one on your green sheet that has the v by itself. I think I gave you this one. V equals d over t. Only what we're finding is relative speed. If the bad guys are standing still, 320 divided by 20, which is, I think, 16 meters per second. And it's meters per second because I put in meters in second. Are the bad guys standing still? Well, first of all, Daniel, what units did they give me the bad guys' speed in? What units did I calculate the relative speed in? Let's convert it to kilometers per hour. How do I go from meters per second to kilometers per hour? I know it has something to do with the 3.6. Is it divide or is it times? I don't know. Hopefully you put it on your green sheet. This is what I'm suggesting you look at your green sheet. I'm not going to figure it out for you. To go from meters per second to kilometers per hour, it's... Oh, okay. So VREL is going to be 16 meters per second times 3.6. You know what? I think I can do that in my head. 16 times 3 is 48. 16 times 6 is 32 and 32, 64, 86, 30. I'm wimping out. Good gosh. I should be able to do that in my head. 57.6, is that right? That's how fast the police have to travel if the bad guys are standing still. Are the bad guys standing still? I'm going to say almost the same thing. Listen close, Jordan. That's how much faster the police have to travel than the bad guys. That's the relative speed compared to the bad guys. How fast are the bad guys traveling, Dorian? It tells you. Yeah. So, ready? The police is going to be 150 plus the 57.6, the relative speed. And they're both in kilometers per hour, so Evan, my units match. How fast does the police car have to be traveling at? 207.6 kilometers per hour. That fast. I like that question. I like that question. I like that question. Okay. Got a couple of videos to show you in just a second, but what's your homework? Everything. I'm going to make a little note here. Number 1 and number 2, I encourage you, if you can't remember how to do this, for number 1 and number 2, look at example 2. That was where I did a couple of train questions. Okay. Number 4, so look at the cheetah zebra question that we did in the notes for number 4. Number 5, police car, look at the one we just did. Number 6, police car, look at the one we just did. Number 7, train question, look at the train question. Number 8, police car, look at the one we just did, except in number 8, what am I asking you to find? Not the velocity, but the time. So see if you can figure that out. It's going to be fairly similar to what we did here, except I'll know I'll be able to figure out the relative speed or relative velocity. See if I can calculate time. You'll probably have to do some conversions along the way too. Okay? Number 9, same idea. Number 10, another train question. Number 11, another train question. Another train question. These are tricky, Jordan, and I'm very deliberately going to let you wrestle with these during class today, but I'll take lots of questions about them next class. Okay? So your homework is going to be pause the video for 1 second.